Good morning, good afternoon, all. We're just going to wait a minute or two, just let a few last minute participants join in, and we'll get the presentation started in about 90 seconds or so. Your last minute coffees or anything to keep you in tune. All right, Manny, you ready to go?
I'm ready to go.
All right, sounds good. Well, good morning, good afternoon, everyone. My name is Chris Doran. I'm a technical sales specialist for ITM Instruments. Thank you for joining our webinar. This is introduced and produced by ITM University. Today's topic will be gas, air, and partial discharge leak detection, new predictive and preventative maintenance solutions from FLIR. Throughout the presentation, we're going to ask you to kindly mute your microphone. The presentation will last anywhere between 40-45 minutes, and we'll have time at the end of the presentation for Q&A. We do encourage you to ask questions at any time throughout the presentation. Simply use the chat feature, and we'll get to your questions, like I said, at the end of the presentation during the Q&A portion. ITM Instruments has been working closely with FLIR for many years. We pride ourselves on being a leading distributor of FLIR. This is a result of our dedication to offering you our product expertise, service, and competitive pricing. Today's webinar is presented by Manny Elsaid, Eastern Canada District Sales Manager, and looks after all solution segments, including industrial, automation, fire, OGI, building, science, drone, volume, XTech, OTS, and security. Manny has been with FLIR since 2012. Manny, I will turn the presentation over to you.
Thank you, Chris, and it's a good thing you did that all in one breath without falling short on the thing. So thank you everyone for joining us this afternoon or the morning for our presentation. I really appreciate ITM's help in setting up this collaborative training overview of the technology that FLIR can offer. And I thank you all for joining us. Chris, are we still waiting for people to trickle in, or can I go ahead and start the presentation?
I think we're okay to start off now.
Okay, perfect. I'm just going to close this so. Excellent. So let's start off. So today we're going to be reviewing the different technologies that FLIR has to offer for the leak detection and the. Let me just switch the slides. Next slide. There we go. Leak detection and predictive and preventative maintenance solutions. As some of you may know, FLIR has been around for a very long time in the early 60s, and then over the years we've added new technologies and new methodology. And as of recent, the FLIR Si124 ultrasonic imager. In today's presentation, we're going to be going over the leak detection, the new GF77 gas detection camera, using the Si124 for air leaks and partial discharge, some overview of the predictive preventative maintenance solutions and how to work safer every day, and obviously some questions and answer. And if we have some time, I'm going to be doing a quick online demo of the FLIR Si124 cloud service. So let's go ahead and start. So, leak detection and overview. Of over 3,000 utilities in North America, in the US and Canada, but those that distribute electricity or do transmission or generate electricity, which is combined basically of nuclear, natural, coal, and renewable energy, just like in Quebec. I'm located in Quebec. We have the Hydro-Quebec. The major issues that all of them have is, do they have some kind of gas or air leaks? As most of them do, there is some kind of a gas, whether it be the SF6 or compressed air systems for work. So they're typically very hard to find. And oftentimes they aren't sure, because if you can't see it or hear it, you don't know if you have it. That's one of the major problems and hurdles that everybody faces in the industry. These leaks will cause safety and environmental hazards. That is definitely a case for, especially in the type of domain that you're in. They also obviously cost money if they are not fixed. They will cause partial discharge failure. Now, this is something that I'm going to just get into a little bit later when we get into the Si124 to explain what the partial discharge is. our solutions are designed to improve reliability of the operation and to also have every employee to have some sort of access to a camera, would be a thermal camera or some other system that we offer. One of the typical things that we always hear about in the industry is, well, thermal cameras are very expensive and hard to, not everybody can have it. And that's actually not the case. So that's why we're here today, to explain to you how our solutions can be a cost benefit in a variety of applications for you, especially in your preventative maintenance. Now, in the gas world, gas leaks that are typically hard to find, the standard methods have been around for a long time to find gas leaks. It's called the method 21. Some of you might have heard of that before. It's basically, you have a probe that you got to get near a leak source with a technician, as you can see in the image. He's trying to listen for the leak, and identify if there's a leak. The problem with this methodology is, as you can imagine, it's hard to do. You have to be very experienced in what you're doing. You have to follow safety procedures, and you have to be very close to this leak, which means you might be exposing yourself to dangerous hazards. That means you have to wear special gear. So it's not an easy process to do, very cumbersome, very difficult to accomplish, and you have to be very well trained to do it. They also use the Snoop test. Basically, it's a soap that they pour on the leaks to try and see bubbles. But again, you got to be very familiar with what you're looking for and what you're identifying. So there's a possibility, and definitely you will miss leaks if you did not know where to look. So our methodology, is to address the facts that these technologies or methods are time-consuming. Again, hard to find where the leaks are. You got to know where to look. That's where the problem is with those methods. The problem is with gas leaks or any type of leaks is they often will move around. They're not stationary in one spot, especially if there's any kind of wind. So we might sense there's a leak, there's actually no leak, it's coming from somewhere else. Again, very dangerous, especially around energized equipment. You will miss these leaks. I guarantee if you don't have the right technology, right methods, you're going to miss a lot of leaks. Method 21, even though it's a common method that's been used for a long time, it's not actually it doesn't find most of the leaks. It probably finds about 20% of the leaks out there in the petroleum world. And you're also wasting, whether it be if you're some kind of a coal generation plant or using gas to generate power, you're wasting a lot of this energy into the world, and also affecting the environment. And you're, especially with the SF6, and you're risking safety. Any kind of leaks, whether it be SF6, or SF6 not so bad, but methane leaks, those are very dangerous and can cause explosion and probably loss of life. Typically, your employees wear, your PPE gear. Everybody hears about PPE these days, but in the industrial world, PPE is it's good to protect you from arc flashes or a certain situation, but it doesn't prevent accidents. Just like the concept is, you don't drive without headlights at night. Of course not. Same thing is, why would you do electrical work in the dark? So basically we see it as, if you don't have the right tools for the application, like an infrared camera or an Si124, you're basically working in the dark. You don't know what's happening. Yes, you can have protective gear, but the protective gear is just protect you from the accident. We're trying to prevent you from having an accident in the first place. So as we say, there has to be a better way. What if you can scan large areas like they call it a remote methane leak detector fast? What if you can really see where the leak is coming from without using the Snoop test or the sniffer test? And what if you can document this? That's actually a very important, crucial point. It's good to do an inspection. It's good to find a problem, but you have to be able to document it and make a decision. If you don't have the capability or an instrument to help you document this information, to make that critical decision, you're pretty much at a loss, because then you have to start writing things down somewhere and tracking it through Excel files and paper, which is very cumbersome, not very efficient. This is where the GF77 comes into play. So the camera was introduced actually last year. The original filter that we had on the camera was designed to do methane detection. With the recently we introduced a new filter, which I will get into later. It's a lens with a new filter that allows you to do SF6, ammonia. And now, since this is a thermal camera as well, you can actually do thermography. So you can do your hotspot detection if you like as well. Let's give you a bit of a background of how gas imaging works. That's sort of a question we get a lot, is how do we see gas? And can every thermal camera see gas leaks and all that, whatever they may be, whether it be a SF6 or methane or ammonia? And the answer is no. Not every camera can see gas. You have to have a special technology or filtering into it. So how does it work? When there is a leak, whether it be SF6, methane, whatever the concept may be, let me just back up here. Everything in the universe, equipment and all that, will emit infrared energy. So that energy is being emitted by an object that goes to the infrared camera detector. When there's a gas leak, some of that energy is absorbed by the gas. So there's less energy going to the detector. So the absorption rate of that gas is what we look for. The infrared light exists in everything, as I mentioned before. Everything in the universe, as long as it's above 0 Kelvin, will emit infrared energy to different degrees. And we have cameras with different detectors for different wavelengths. Infrared is something we don't see, but we feel. If you ever felt heat from a baseboard heater, oven, or sun, that heat you feel is the infrared energy. Our cameras are designed to capture infrared energy in different wave bands. So there's mid wave, there's long wave, depending on the application. So as I mentioned before, the gas is absorbing some of the energy getting to the detector that's being emitted by the surface around it, would be the sky, the wall, or whatever it may be. We find what the absorption rate, the peak absorption of that gas is. We filter it out and allow only the energy that is not being absorbed to get to the detector. That's how we're able to really kind of tune it. Now, this is proprietary, so we don't actually show you what the wavelengths are that we're filtering to, but we give you an idea. But also, it means not every gas is being able to be picked up by the camera. So the GF77 will not see every potential gas leaks out there in the industry, just as any of their other models that we have. Hence why we have cameras that are designed specifically for methane, CO2, carbon monoxide, refrigerant gases like the R22 or SF6. In the case of GF77, we have lens options to allow you to switch between the methane or SF6. So they're designed specifically with peak absorption, we call it, to the filtering to be able to see those gas leaks. Here's an example of a fuel gas skid methane leak that you see, that typically, if you don't know there was a leak there, unless you have some kind of a sniffer test or you're aware of where to look, you could be looking for hours. You know that you're getting a leak because you're seeing a quantity change from what's being used versus what's being pumped into it, but you don't know where it is. A optical gas imaging camera from FLIR will allow you to easily see where the leaks are, and then you can document by capturing videos, images, and putting those into analysis for reporting. This is a flange leak from another methane leak you see. Here's an example. I'm just going to start the video. And again, you see there's a methane leak. We have different modes to allow you to kind of improve the sensitivity of the camera. That's why you're kind of seeing the switch mode. This is a regular high sensitivity, this is a high sensitivity mode. This is the regular infrared mode. And then you also have a visual camera included onto your camera to switch. So you can record in one video, find a leak, document it, switch over to visual to identify where you are when you're doing your scanning, if you have to show this to someone. Here's an example of an SF6 leak on an insulator. I'm just going to start. You can see the leak is right there. And again, we have high sensitivity mode. There's the sky in the background that's causing this effect. And again, SF6 is typically hard to find, but you can see there's quite a leak in this substation being done. And as I mentioned before, the GF77 is also a thermography camera. So you're able to do your hotspot detection. We're looking for min-max temperatures, do delta T's between 2 points, compare so you can capture these images, write comments, create inspection routes. All these things are also part of the camera design. So let's look at the portfolio of what's being offered. The camera can measure from -20 to 500 degrees C. The camera has onboard routing. Now, if you're not familiar with it, we can definitely set you up we can do another webinar with ITM to explain to you the onboard routing. But last year, FLIR introduced a new routing feature where you're able to create a routing work. So basically, you program into the PC, into your computer, a route to a person should follow from locations, equipment, assets, so on and so forth. Load that into the camera, and the technician is able to follow through specifically without making a mistake where they need to go next. And this can be repeated over and over. So consistency becomes easier. Creating historical information is easier. You're not guessing, basically. You don't have to kind of group everything by SD cards. You can just do it straight on the camera. The accuracy of the camera is now ±3 degrees C. So again, we offer 2 different lens types. So let me repeat that again so it's kind of clarified. One camera with one lens combination has a spectral range of 7 to 8.5 micron, is designed for methane and secondary gases like sulfur dioxide, nitrous oxide, and even refrigerant gases. And to be honest with you, more and more gases are being added over time as more and more tests are being done. But typically, this is the gases you would use. This is what the lens that we use for this. In this configuration, we have two lens options. We have a 25-degree lens and a 6-degree lens, as a zoom lens we call it. In the HR lens range, which is designed for 9.5 to 12 microns, so this is another lens that has a filter for the SF6 gas and secondary gases like ammonia and ethylene. And again, there's a 25-degree lens and a 6-degree lens. So these are basically, there's 4 lenses here. This is not one lens doing 2 things. There's a 25-degree HR, 25-degree LR, 6-degree LR, and 6-degree HR. To give you an idea of pricing, again, you can ask ITM for price. I just wanted to kind of put it in just for reference. So the kind of price point. So for one base model camera with one lens of either LR or HR, it's about 40,000 Canadian. And then as you go up, if you add more lens, and you can buy with a full lens package, it goes up obviously in pricing. Now, let's get into the Si124. This is FLIR's new acoustic imaging ultrasound camera. In the industrial world, sorry, let me go back one step here. In the industrial world, our engineers and business development team looked at this graph. This is actually a common use graph in the degradation of equipment, in the early failure of equipment, we call it. You know, something is designed and built, it's run in operation, has a lifetime. As the failure, everything fails, typically that's, especially in the industrial world, and will fail, there's a certain sequence. Some of the inspection procedures used to find failures are ultrasound, vibration, oil. But what you're going to notice is what picks up early stages failure is actually ultrasound spikes. Then afterwards, they could, depending on the type of equipment, you can do vibration analysis. And again, depending on the type of equipment, you can do oil analysis. But if you notice, actually, thermography is way down. It's more of a middle way of a point. Before there's a hotspot issue, the ultrasound will pick it up much faster. So that's a major advantage. You can capture early failures way advanced in the degradation of the equipment failure before it even gets to the hotspot temperature reference point. Now, what is ultrasound? You guys have probably heard this before. Ultrasound, variety of. This is not the ultrasound that we use for, see if there's a baby and all that. It's a similar frequency, but it's not the one we're not looking for babies in this one. Looking for air leaks. So, ultrasound is high frequency sound waves that we don't hear. It's beyond our human hearing. It's produced typically by operating equipment in electrical, or by air leaks. They're very directional in their sense. Because of their high frequency, they tend to be very directional. They don't actually spread out easily. So as being so, makes it easier to find the source, and it gives us a good way to give you early warning of a failure. So it makes it easier to do literally for predictive maintenance and asset management, it becomes very easy to be able to do the good diagnostic. Now, how do we do this? So we have multiple microphones on the Si124 to allow you to triangulate the source of the ultrasound. So having more microphones without being too big allows you to have a good way to triangulate the source of a problem. In our camera, we have 124 microphones with a 5-inch LCD screen. So the LCD screen is just a black and white screen, and it will show you the source of intensity of ultrasound in color. So as you see here, as example, this is an air leak. You're seeing what the air leak is, you identify the source right away. And this actually saves you 90% reduction inspection time. So it's a very quick way to find. The camera is very easy to operate. There's no on button. You just plug in the battery and you're ready to go. It's a one-handed operation. And just like in our thermal imaging cameras, where you have the more pixels you have, the better the accuracy and resolution, or the better ability to detect small targets, we did the same thing with the Si124. We have 124 microphones to allow you to properly triangulate the source of the problem. Our camera is able to see leaks up to 100 meters away. That's pretty impressive. The typical applications that we are presenting this to right now for the Si124 is mainly the electrical partial discharge, compressed air system leaks, vacuum leaks, and obviously there is other industries as well. But these are the main ones we're going to be focusing on today. So let's look at the air leaks and how does it affect our overall cost of consumption. The US Department of Energy estimates that 30% of the manufacturing electricity is actually used up for compressed air. Now, of that 30%, they say about 1/3 of it is lost to air leaks. So 30% is lost. Of that 30% of electricity that we use, 30% of it is actually in losses of air leaks. If you take a typical 200 horsepower compressor running 6,800 hours per year at 11 cents per kilowatt hour, that's a $40,000 savings if you can capture that leak and fix it. Now this is just one. Imagine if you have multiple air leak problems within your production facility or your warehousing. Now, why ultrasound? Well, typically an air leak system, a compressed air system is pressurized. When there's a leak, it will cause a turbulence and creates ultrasound. If the air leaks too easily if there's not enough pressure and it leaks into the air, it dilutes, we will not be able to pick that up. However, the camera with this filtering and ability to kind of tune out, you're able to really get a good way to know where the specific point is. You have tools and settings in the camera to allow you to better filter out any background noises that might affect the camera. So our camera measures temperature from the 2 kilohertz up to 31 kilohertz. Typically for air leaks, it's under I believe the 10 kilohertz, and for the power discharges, typically from the 20 to 31 kilohertz. Here's an example of a compressed air leak system. This is just a joint that you see that the camera is identifying and clearly showing us that there's a source of a leak right at this connection point. This is another example. So again, what the camera is showing you is there is a leak for this potential point, not at this point. And it's easy to identify. It's not, I mean, the image is clear. It is black and white, but the reason we did it that way is just to make it easier to identify the leak source. If this was a color image with a color spot, it would be hard to see. So we made it black and white to make it very easy to identify where the leak problem is. Now let's get into partial discharge. What is that? So what classifies partial discharge? Corona. You probably guys have heard of, not the virus, but the corona effect, which is ionization of the fluid or air around a conductor. That's the corona effect. You might hear, if you hear buzzing sound sometimes from electrical towers or equipment and all that, there's probably some kind of a corona effect happening. Now you probably will see an interference in your electrical equipment. You drive by with the radio or something, and you're going to see, that's typically a corona effect happening. And everything I can tell, in electrical, typically there's a lot of corona effect, but some of it can be very severe that can cause a problem. Another one is tracking, which is surface contamination. Something is basically tracking to and causing defect. And then obviously the arcing. You probably might have seen this video, the arcing between 2 points. It's a breakdown in the gas and produces a plasma discharge. Now, one thing we did with the Si124 that is very impressive. When you're doing a scanning, you're able to connect the camera to the cloud. The cloud will process whatever images you capture and determine what the problem is. So let me repeat that. You're doing a scan, you find a fault somewhere, you capture an image, that image goes to the cloud, does AI analysis, and it'll give you a determination of what it might be. Is it corona negative? Is it corona positive? Is it discharge between two components? Is it a failure of an insulator? It will tell you that, and I'll show you that a little bit later. Here's an example of a faulty insulator, like the typical that we saw the SF6 leak from. As you capture the image on the cloud and the reporting, you're going to get a sample of typically of a 2-second, which we don't hear, we just see it as what was sampled of the image, and this is the pattern. And the camera will give you, or excuse me, the AI software will give you a determination saying this is a discharge on surface or inside a component. It'll really give you basically a probability of what it might be. Again, another example of the corona effect. This is inside a cabinet. Excuse me, not inside. This is another insulator between components. When you run your analysis, if it's a compressed air leak, you will actually see a cost per year and the rate of the leak. So in this case, we see an air leak of 2 liters per minute, and it's costing, in this case, they put euros, which I'm going to show you afterwards. We can obviously put it to dollars, what the cost is and the example. So in the air leak example, you will see this type of analysis. What's interesting though is if you're out in the field, you're doing inspection analysis, you want to know what this is right on the spot, you can connect it to your mobile phone and get analysis right on the spot. So while you're on mobile phone, you log into your account of the camera, you do your diagnostic, you've captured the image, the AI is doing the work, and it's showing you this is surface or internal, for example, in this case, probability, the surface or internal damage, or some of the other options as well. So what are the features of the Si124? It can do both air leaks and partial discharge. It's very lightweight. I would say it weighs 2.2 pounds and you can literally use it with one hand. The battery plugs in, you can put the battery, it goes into your belt pouch, and you can just use one hand to walk around and do your inspections with a 5-inch LCD screen, very impressive side screen. You can see the leaks or partial discharge from up to 100 meters away. So quite an impressive unit to how far you can operate. You can basically detect something from. You don't have to be that close. Remember, one of the issues with the method 21 or any of the other type of methods used to do inspections is you have to be close up. This, you don't have to be that close. You can be far away. The battery can run for up to 8 hours of running time. Again, it has the Wi-Fi connectivity for the cloud AI, as I showed you before. 5-inch color screen. It can be operated -10 to 50 degrees C. So it's a very versatile tool to be very flexible to your, basically to your operation world. I put it here, is this actually US dollars? This is not Canadian dollars. I just want to make sure it's 20,000 US or 27,000 Canadian, the camera. Any questions so far, Chris, before I jump onto the website to kind of do the demo of the software and the reporting?
We have a few questions that came in, but we have plenty of time. I'll just remind people that if you do have questions coming in or you do have questions, please use the chat feature. Manny, if you want to go to the cloud demonstration, we can get to these questions afterwards.
Sure. So I'm going to log into the Si124. So each Si124, you can create a cloud account to allow you to log in and basically do your analysis. As you capture images, they're uploaded into your account. These are examples of the customer demos that were done at different sites. So let's look at the partial discharge problems here. So let's look at this one, for example. This was done recently, I believe. This was done November 20th. So just basically 20 days ago, quite recently, by one of my agents out of Atlantic Canada. You see the image was captured. You see the problem source. The AI is saying this is a 100% corona negative based on this application. You can write comments and you can have all that information put into the report. For an air leak, let's look at what it gives you as an example. Now, you can, in the settings of your cloud account, you can put in your value for kilowatt hours, in this case, Canadian dollars and kilowatt hours. And now the camera will calculate the leak rate, which is saying that this leak rate is 1.8 liters per minute, is costing you $22 a year. So if you have a combination of multiple leak points, a variety of this warehouse, it'll give you an overall cost. Let's do a report with leaks to show you what that looks like. Let's select some image. Go back here. I'll use this one. So you do is generate report. The camera knows, the AI knows that this is a compressed air leak. This is not a power grid report. Mind you, I've selected images from previous demo, but knows these 3 images are compressed air leaks. You create generate report. It will do a process to create a PDF report. It takes very quick. Obviously depends on the connection that you have for your internet. Report is ready to go. You open it up. Now this is very, very interesting. We have gives you how many snapshots you have in your report. If there were some that the camera or the AI could not pick up what it was, it will put 0, it will put your number without result. But it'll also give you a summary, how many leaks you have, what the total leak size is, what the minimum and average and maximum leak size is, and what the overall cost. to show you what is your critical repair. You know, this is going to cost you this much per year for this type of leaks. So if you imagine a report of 100 images of different leak points, and trust me, there's compressed air systems will always have leaks, you're literally going to see the cost factor of wasted energy, basically. In the power grid report, let me just select all the images. I'm going to select 3 images now, but this one as well. Now the camera knows that based on the frequencies being picked up by the ultrasound camera, these represent power grid report. We generate. Now this is going to give you a different format of a report. And you can do both at the same time. You're not limited to do one or the other. You're able to come, well, so excuse me, let me correct that. You're able to do a power grid report or a air leak report from the same account. So open it up. So now again, you have the summary in the first page, how many snapshots, and how many, if there was any without result, and some with the result. We go to the next page, you have an example, acoustic camera. It's saying that this is a surface or internal damage. This could be discharge to the equipment. This is a transformer, that there's degradation in the wall. And the customers actually, this was a demo done by my agent, and the customer's gonna look and see what's causing this problem because they believe there's an issue happening. They didn't even know that this was a problem before. So this was they were impressed by this, what was caught by the camera. In this case, it's a partial discharge, and it's showing it's corona negative. Another one here is showing you corona negative probability with a positive. Forgive me, I don't know what the difference is, but I know if you want more information, I can definitely get you that information as well. So this is the overview of the software. Please let me know if you have any questions. I'm going to go back to the slide and just put this on. Let's swap this. So any questions, Chris, from anybody?
Perfect. Thank you. Before we get into questions, Manny, thank you very much for the presentation. I know we're all probably thinking the same thing, lots of information, so I'm sure that you guys have plenty of questions. And good thing is that we have plenty of time to get to any and all of them. So please use the chat feature. If you have, just to start off, if you have any questions about pricing, availability, sale, rent, or anything along those lines for ITM directly, I'm going to encourage you to visit our website, itm.com. You'll find out all our contact information there, as well as you can browse all the technical documents for the GF77 and the Si124 there as well. So a question that came in during the presentation, Andrew asked, what for the calculation and the cost analysis in the cloud, what source info is the AI using to generate that cost analysis?
For the partial discharge, or sorry, I missed it. Was it compressed air leak or partial discharge they were asking, or both in this case?
Yeah, it'd be both in this case. So
it looks at the frequency that was captured, and depending on which one is captured, then it decides which AI to use. So it says based on, and plus it does sampling. So it has a sample. If we go back to that report here, let's see if it's still on. Based on what was historically captured by our internal information, it compares to this frequency response to what it is. This is based on what we've found out in the past, and this is what we have as engineers have determined. This is a corona negative. In the compressed air leak system, it just knows that the frequency measured is such. This is saying here 21 to 31. If I go to the compressed air leak, I think it's this one. It's basically up to 3 kilohertz. So he knows right away this is compressed air leak. This is the pattern that's being seen. This is not a partial discharge, therefore it's a compressed air leak because it's continuous. It's not a kind of a ticking sound. So it does it says this is a 1.3 liter per minute at this much Canadian per year.
Okay, I'm going to get you to stick on that slide actually for a second.
Oh, okay.
Because Andrew's question was more based on, it was probably myself not elaborating fully, is how does the cost analysis work in terms of the AI? Is it pulling from source information? Is it tabulating the data, liters per minute, tabulated by what the estimated cost would be? I think it's more generated his question.
Correct. It's based on the the kilowatt hours cost is based on this, and this is where the specific. I will get that information for you, Andrew. I do apologize. I don't have that specifically how that's being done by the AI, but that is based on the cost value that's here, 12 cents per kilowatt hour. Based on the factor, this is based on leak size of 1:1, basically. So if you want to make a correction, this is where we put a correction. Right now we left it as 1:1, but if there's a correction you need to add, you would put it in. And this is liters per minute, and this is where the calculation is coming from. But how is it done to know it's $16 per Canadian per year? I'm not sure. I'll have to get that checked by I'll ask my developers to see where that's coming from.
Okay, perfect. And Andrew, if that doesn't answer your question fully and we don't get a chance to get to that during the webinar, we can always take this offline, revisit it, and provide the full detailed response to you offline as well. If you do want us to do that, I would just ask you make sure that you send us your email address if we don't have it already, and we'll follow up after the webinar. Another question. So question from Chris, would it be able to pick up multiple leaks at the same time?
Yes, so you could switch on the camera. I don't have a screenshot of that, but you have the ability to switch. Now the camera has a touch screen. There's actually no buttons other than the image capture button, the trigger in the front. You're able to switch multi-source or single source. So if you want to pick up multiple leaks, you switch to a multi-source. It's a little icon that shows you 3 dots versus 1 dot, and that's how we switch.
When using the multi option, how do I word this? Do customers and end users need to be careful of reflection?
Yes, obviously the reflection is actually just like in thermal imaging. There is potentially, so it is something you kind of have to play around with and see. You kind of move around as well. Same thing with thermography. You do move around to see if the reflection moves, and that'll tell you if it's a reflection or an actual source of a leak. We have a training, RTC training, that gives you that will give you more in-depth knowledge of understanding how to properly do ultrasound imaging, and something that ITM can send you information on. But yes, it is something you have to be aware of as well.
Perfect. Another question comes in. So how big or how small does an SF6 leak need to be in order to pick it up?
The SF6 leak has to be, I believe it was 500 particles per million. So it has to be a good leak. It's not. If you're looking for small leaks, the GF77 is not the right camera. You have to go for the GF306. That's a camera that's designed. It's a cooled mid-wave camera designed for very small SF6 leaks. The GF77 is more the generalized SF6 leaks, and you would know this by the calculation of how much. So if you're a utility and you're adding SF6 to your equipment, you would be able to calculate how much is lost. That will help you determine, okay, I'm getting this much loss of SF6 over time, so my leak should be around this. Then you determine which camera to be used.
Perfect. So a reminder, we do have a lot of questions coming in. Please don't be shy. Use the chat feature. We got plenty of time to get to any and all questions, and I urge you to take advantage while we have Manny here connected to send us any and all that you've got. So the next question, this is more cloud-based, I guess. Do the reports remain on the cloud? And if an end user or customer decides to give a customer of theirs access to the report, to the cloud itself, would they have access to those reports? Or I guess maybe it has to do with how can an end user share the reports that are generated?
So the reports that you generate are PDFs that get stored onto your local computer. There is no reporting stored online. The only thing stored online is the imagery and the AI analysis, but everything is stored onto your local PC. And then if you want to share a report, you would just email them the PDF copy.
Perfect. And along those lines as well, I'm assuming that this is the case, but let's touch on it anyway. Is the GF77 compatible with the FLIR tool software?
Yes, it is. So the GF77 still captures radiometric JPEG images. So the JPEG images can be opened in any Windows and even actually Apple platform easily. But with the radiometric data stored onto the image, with our software being either FLIR Tools and or Thermal Studio, the new one we introduced recently, you'll be able to analyze the images, do your delta points, write comments, and then generate PDF or reports to be able to share with people.
Fantastic. All right, next question coming in from Gordon. Can the acoustic camera also detect hydrocarbon leaks, or is it only air?
It can, so the acoustic camera can detect any leak as long as the leak is pressurized enough to create turbulence to generate ultrasound frequencies. So we can't tell you what that is, but as long as the leak is pressurized, if it's a leak, if something is, the SF6 might not be, an insulator might not be pressurized, right? It's not that much pressure. As you saw the example of the GF77 SF leak, the Si124 would have not seen that leak because there's not enough pressure to create an ultrasound frequency to see that. However, if whatever you're looking for is pressurized, there's a good chance that it's as the air or whatever the gas is being emitted is turbulent, it's generating ultrasound frequency.
Perfect, thank you again. Once again, if you have any questions, please use the chat feature. Let's see. We have a question that just came in from Clay. This has to do with software and cost of subscription. Clay, if you want, in terms of questions about pricing, availability, software related, camera related, anything like that, visit us on itm.com. Find out our contact info, our email address. You can contact us via the chat via itm.com, and we'll follow up with you for any cost related answers for either camera that we touched upon here. Let's see. So does leak detection require direct line of sight, and or going into this a little bit further, would the Si124 be able to detect a leak behind a wall?
I should say I've never seen it yet, and I don't believe you can. Remember, the ultrasound frequencies are very directional. So if there's enough getting through the wall, potentially. So in a cabinet, if you have a closed cabinet and you want to see this partial discharge, you will see something being emitted and all that. So we'll be able to kind of, that is kind of part of the reason of the tool. But to say specifically, I don't know if the AI will work as well because the ultrasound frequency is being absorbed by whatever the surface is, so it probably won't be as accurate. But it'll tell you there is something. But obviously, it depends on the wall material, depends on the distance, depending on the conditions. So it's a hard answer. It's not easy something. I can't just say it 100%. It really depends on the conditions.
Perfect, thank you. What about ambient air temperature? Will that affect either camera's results?
So if you're using GF77 in cold weather, and typically one of the things I tried to explain was the gas absorbs the infrared energy emitted by what's around it. Here's an example. In the summertime, when you put gas in your car, I'm sure you guys have noticed that sometimes you're going to see the fumes kind of distorting the image around you. Now, why? Because there's enough heat around that the gas is absorbing it, and it's kind of affecting your view. It's that much that it's actually touching the visible range of our electromagnetic spectrum. And if it's too cold, if there's a little energy that the gas doesn't absorb as much, the cameras might have a harder time detecting the gas. So we always make sure that you want a good difference between the two. What that is, it really depends on the temperature of the gas to what the background is. We like to have a bit of a delta T between the two. So in the cold weather, if the gas is hot though, so in that system, if the gas is warm for whatever reason, because it's the process, whatever, it'll be fine because it has enough energy to send to the detector. But if the gas is just ambient, under pressure, the same temperature of what's behind it, or very cold, you might have a harder time. So it really depends, but just make sure you need a delta T between what's behind it to what's being absorbed by the gas.
Perfect, thank you. Another reminder, everyone, we still have about 15 minutes or so to get to your questions, so please use the chat feature. Next question that's coming in from Dina, it's more of a, I guess, an industry question more than camera specific, is in your experience, do utilities or utility companies typically purchase these on their own, or have you seen companies, maybe inspection companies or anything that provide this type of service using the cameras?
So I've seen both. It depends on the size of the utility. If the utility is large enough and they have a team that is designated to do this type of inspections, they'll buy their own and do their own inspections. If the utility is smaller, private, localized utility, and again, there's so many of across all, they will then hire someone out. So it varies to I can tell you there's a market for both. Utilities will buy for themselves, and I have companies that I work with that buy equipment and do their own inspections as well.
And kind of tying in with that, Andrew has a question about competence and or certifications of, let's say, a customer who decides that they want to provide this type of service. They will, go ahead and purchase one of the GF77s or Si124s or any other camera for that matter. Do you know if there's any specific barriers that a utility company or a company in general would have or require an end user to have to perform these?
So in the thermography world, we offer what's called the level 1 certification. It follows the standards that allows you to make sure that you understand what you're doing and make sure you don't make any mistakes. There's 3 different levels. Level 1 is basically an introduction to to avoid how to make errors, because in the thermography world, you're using an infrared camera. It is a camera, so you just turn it on and start looking, but you have to understand what you're looking at. Just like the issue of reflections and the air compressed air or the Si124, you will also have reflections and sometimes anomalies that you're not sure what they may be. The level 1 kind of helps you, figure out, okay, well, it might be this, not to make a mistake. Then there's a level 2, which become more of an expert to start making diagnosis and writing reports. So typically utilities will ask for minimum level 2, but again, it depends on the utility. Not everybody, and some utilities will actually have their own internal training as well. For the Si124, we have this certificate training for the ultrasound offered by ATC through ITM.
And to touch upon that and just kind of elaborate again, any questions about training, all the information on the ITC training, the different levels, all the information can be found on our website, itm.com, along with all our contact information, email, chat, etc. So if you want any pricing, you want a demo, rental unit, pricing on either of these cameras or any others, you can contact us there and visit our website there.
Just to go back, sorry, to that training. So the ITC level 1, level 2, and even level 3. Level 3 typically is somebody who wants to become a trainer. Your certification is good for 4 years and can be renewed by redoing the exam or other methods.
Let's see, a couple more questions came in. Okay. Can the GF77, I guess both of these, but can the GF77 mainly be mounted to a drone in order to do distance measure?
You can. Obviously, you'd have to make a specialized basket for it to carry it, but we actually have a GF77A, which is a fixed version of the GF77 portable. So it doesn't have the LCD screen, doesn't have a battery. It's a fixed PoE camera, power over Ethernet, or you can do 10 to 30 volt DC. It has no onboard storage, so you'd have to send the information captured to a hard disk, either wirelessly, either on board the drone and or wirelessly to the ground receiving unit. But there is something we can offer as well, but not. I mean, you can use the GF77. I've seen customers use handheld cameras to mount on drones, but we have both options for you, whatever works for you.
Perfect. And we have another question, just to kind of go back to our last question about the training. Peter would like to know, there is a specific Si124 training available?
Yes, from ITC.
Perfect. Okay. Let's see. So I'll use this as a last reminder. If you do have any questions, take advantage. We have a little over 10 minutes to get to any and all questions. Use the chat feature. And here we go. Let's see. It's a question I've seen quite a number of times, having to do with ultrasonic leak detection, but can it be used to detect small leaks around a window?
Yeah, we had that actually question. And so if the air is turbulent around the window, so if there's enough of a pressure change that either there's so much pressure outside or inside that's causing that air to be turbulent, then potentially yes. Is it a right method? I wouldn't suggest. I'd rather you just use a thermography camera. That'll do that. That'll give you a better diagnostic of a window. So I wouldn't use that Si124. But again, if the Si124 has there's enough turbulence around the air leak, then potentially it can. It generates at ultrasound frequencies, then yes.
Perfect. And what about using the Si124 in a very loud environment, very noisy environment? Will it still pick up things?
Yes, so there's a way to actually tune the camera. We have tools and filters on it to allow you to kind of block out certain sounds, so you're really focusing on that. Depending on what you're looking at, so if it's compressed air leak, you can focus it to the compressed air leak band, and vice versa for power discharge. So there's we have filtering. I didn't get into that. That's more in depth. We can definitely do a one-on-one or another webinar, get into that feature set of the Si124.
Absolutely, and I'm assuming that that would be covered in the Si124 training as well.
Correct.
Fantastic. Andrew, I see that you sent another follow-up question about the training. So online, in-person training through the ITC for thermography and other specializations. All the information can be found on our website, itm.com, under the training header. And if you wanted any follow-up questions or anything like that, you can find all our contact information via email, via chat, directly off that page, actually, so that we can follow up with those specific questions as well.
And then we do offer now, sorry, I didn't correct that before, we do have online training, obviously due to COVID. So for the ITC training, it's still a 4-day training course, still a 8 to 4 or whatever it is the trainer does, except it's all virtual. So we'll send you, what we do is we send you the books and the exams and all that ahead of time, and then you can follow along the instructor live as they discuss to show you examples. And we've done a few successful, and actually, ironically, the courses they tend to be very full. We'll have a course starting for next week for level 1, and it's, I think, 25 people, and it's already full. It's complete. So
that's fantastic. Gordon has another question about are either of the cameras presented today or any other intrinsically safe?
So the GF77 or Si124 are not intrinsically safe. However, we do have intrinsically safe cameras. If it is for example, methane detection or any of the VOC gases, we have a camera called the GFX320, which is intrinsically safe camera that allows you to basically go on top of the what's the word I'm looking for, on top of, when you want, let's say the tanks, the big tanks, you want to be able to inspect the doors. I don't remember the terminology, but be able to get into it because it is an intrinsically safe camera. You don't need any special camera for that. So it's a GFX320. That's the only one that we have for that type of scanning. If you want a fixed version, we have an explosion-proof version of a fixed mount camera that can be used as well. But that's not for gas detection. It's more for thermography. So.
And another follow-up question from Andrew. This is more, again, it's software-based. Is the cloud, access to the cloud, is that browser-based, or is that something that needs to be installed and downloaded?
For now, it is browser-based. However, next year, and I know there's going to be an update very soon, and more that we're going to be making more onboard, localized. We've had a few questions about having localized AI and onboard. So you will see changes. So if you do have a system now, your system is going to upgrade, firmware upgrade, and you'll have your account upgraded to be able to do multiple ways of reporting and diagnostics. Okay,
perfect. So theoretically, end user customer can purchase either of the cameras, well, I guess the GF77 will go with, and use the cloud-based reporting, not necessarily needing the FLIR tools or the Studio Pro.
Well, the GF77 doesn't have any cloud-based. It's a PC-based software, Thermal Studio, or Thermal Studio or FLIR tools. The Si124 is cloud-based for now. Again, in the future, by next, I would say maybe next year or two, depending on, obviously depends on the COVID situation. This is where kind of affecting our speed of doing things. Unfortunately, it's as everybody is impacted. We are going to be integrating these technologies, kind of reporting to make it more, together. But for now, it's separate reporting.
Perfect. So,
however, sorry, one thing I do want to add: the Si124 does put out JPEG images, so you can still insert them into Thermal Studio, but you can't do an import feature like you do with just to plug in the camera in and you do it. So you have to go find the image and insert. It'll be inserted, and the software won't do any extraction of metadata, but you can write in comments and kind of put the analysis you have from your report into the Thermal Studio report.
Perfect. Okay, so one last call for questions. You can get them in just under the wire while we have Manny still connected here. Again, if we weren't able to get to your questions, you have any questions about pricing, availability, rental, or anything along the lines. We touched a lot upon training and certification. All of that all the information can be found on itm.com. All our contact information, our email address, contacting one of our inside sales reps via the chat, all can be found on the itm.com website. And it does not look like we had any last minute. So Manny, thank you very much once again for the presentation. Lots of questions, lots of information. It was great. So thank you very much for joining us today.
My pleasure. Thank you. Go ahead.
On behalf of ITM University, we thank you all for attending our webinar today, and we hope you found it informative and helpful. ITM instruments are available to assist you in any way. Once again, please visit us at itm.com. You can find all our contact information. You can chat live with an inside sales rep. For any questions, if we didn't get them again today, please contact us there. At the end of this webinar, we have a very short survey that we'd like you to complete. Your feedback will assist us in improving and allowing us to bring you more topics of interest and that you specifically are interested in us covering. And also don't forget that as a thank you for attending today's webinar, your name will be entered in a draw to win $100 for your next online order. The winner will be announced on our social media channels, so please be sure to check us out there. Manny, once again, thank you very much for the presentation. Thank you all for joining us today. I wish you all a great rest of the day.
Thank you, everyone. Be safe. Thank you, ITM. Take care.
Take care.